Hey there and welcome. Today we are diving into the world of system testing for automotive development, covering 5 stages: MiL, SiL, PiL, HiL and ViL. Now, why are these testing phases are so important? As car becomes smarter and packed with more tech, ensuring that they are safe, reliable and perform well is critical. Each phase of testing has its own special rule, from the first virtual model to real world track tests. These steps ensure that every component works smoothly and we can avoid costly surprises later on. Here is a quick look at what we will cover. MiL, our first step where we sketch out the design virtually. SiL, where we tune that the design into the actual code and test it. PiL, taking that code to the target processor. HiL, testing with real hardware and simulated inputs. ViL, the ultimate and real life tests inside an actual vehicle. By the end of the session, you will know how each of these phases helps to create a safe and high performance vehicle system. So buckle up because we are about to take a ride through the world of system testing. Let's go. Model in loop. First up is model in loop or MiL. Imagine MiL as a blueprint stage. Here we build a virtual model of the system and use it to shape the car's brain. Think of it as a sketching out your ideas without committing to hardware or coding it. In this phase, we are using powerful tools like MATLAB Simulink to simulate and refine the system's logic. This allows us to try out different algorithms and behavior without needing any physical components. Why MiL? It's all about saving time, money, and avoiding rework. By catching and fixing design flaws early, we can adjust the core logic in a safe environment. MiL is used to refine algorithms and detect logical errors before coding even begins, making it highly cost effective. Example: imagine an automatic braking system. MiL lets us test brake timing at different speeds so we know our system is safe and ready to move forward onward. Next up, software in loop for SiL. Here is where we take our tested model from MiL and turn it into the code, running it in a virtual setup. Think of a SiL as a bringing your blueprint to life, but still in a safe or digital space. Now we are testing actual code on a computer, making sure it behaves just like our initial design. SiL is our chance to catch any software glitches before they reach to hardware stage, building a reliable software foundation. SiL is a fast and cost effective, perfect for refining software in early development. Let's say we are testing the brake code in a virtual setting, ensuring the brakes are triggered right on time. This phase is all about making sure our code is rock solid before it reaches to real world hardware. Next stop is PiL. Welcome to processor in loop or PiL. This is where the code gets real. PiL lets us test the code on actual target processor, which is the real chip that will eventually be running in the vehicle. Here we load our code onto the target processor and connect it to a simulator to check if it can handle real world demands. PiL helps us to ensure our processor has enough power, memory and speed to handle its job, allowing teams to verify timing and performance, ideally for late stages testing to catch processor specific issues. Example: imagine a processor handling a rapid brake calculation in a busy traffic situation. We'll test if it can keep up those demands without lag. PiL is the last step before we bring in the actual hardware. So let's move on to HiL. Hardware in loop. Now we are getting hands on with hardware in loop or HiL. Here we combine our software with real hardware like electronic control units (ECUs). Using simulator, we mimic real world conditions so our hardware reacts as if it's truly on the road. Why is HiL is important? It's essential for validating that our hardware and software work perfectly together, especially for safety critical systems like braking and steering. Example: suppose we want to test braking in a rainy condition. HiL let us simulate a rainy day and check that ECU triggers ABS correctly without putting anyone in a danger. With HiL, we are one step closer to real world testing. Ready for ViL? Vehicle in loop. We are reached to the final stage, vehicle in loop or ViL. This is where everything hardware and software gets tested in a real vehicle, typically on test track. ViL is all about seeing how the entire system behaves under real driving conditions. With ViL, we observe interaction between multiple systems, making sure that car is ready for any scenario. Here is where we confirm that vehicle's braking, steering, powertrain, and other systems work together seamlessly in real world conditions. Example: testing an automatic braking system can be on the track to see how it interacts with other systems like steering and powertrain. This ensures the vehicle's safety and performance are good to go. Wheel is the final check before production. Now let's recap. Here is a quick rundown of our system testing journey. MiL starts with the virtual model to refine the design. SiL brings that design to life of testing actual code. PiL run the code on the target processor to verify its performance. HiL integrates the hardware and software, simulating the real world condition. We'll test the complete system in a real vehicle on the track. That's wrap up on our roadmap to system testing. Thanks for tuning in. If you enjoyed this session, don't forget to subscribe for more updates, and if you have any questions, drop them in the comments below. Let's keep exploring the world of automotive testing together. See you next time.